So welcome to our final lesson on 3.8. This is the final lesson on Chapter 3. And finally we're going to get around to the idea of using these matrices that we've been working with in the last couple of lessons, using matrices to solve systems of equations. All right? And so you'll notice, first of all, that these notes are not the notes from your student text. I did pass out copies of those in class, but if you were absent on the Moodle, then you can use the Moodle site to print these notes so you can fill them in as you follow along. So the first part of this is really akin to section 3.7. So we have to first talk about finding the inverse of a matrix, so that way we can actually solve a system using matrices. So the first part is, it says finding the inverse of a matrix. All right, the inverse of a matrix is defined as follows. First of all, the inverse, we use the notation a to the negative 1 to represent inverse. So the inverse of matrix A is A inverse. It is 1 over the determinant of matrix A. And then if matrix A was A, B, C, D, effectively what we do is we reverse A and D, and then we change the signs. So I'm going to say switch. We're going to switch these two, and we're going to change the signs of those two. All right, and so to calculate the inverse, you first need to find the inverse of the matrix, and so we're going to need to find the determinant. All right, and so I guess the first part of this then, before we even get into the inverse, is to talk about the determinant. The determinant of matrix A is simply A times D minus B times C. So we take the product of those that are basically on diagonals and we subtract them, AD minus BC, and that tells you the determinant of matrix A. Now, there's a note down here: as long as the determinant is not equal to 0, we can calculate the inverse of that matrix, matrix A. So again, by definition, the inverse of matrix A is the scalar multiplication of 1 over the determinant of A times AD gets switched, and then B and C get the sign switched. All right, and so basically this part right here is that determinant of A, 1 over AD minus BC. And then this is kind of the long-winded version of the whole thing, and that looks quite confusing and a little bit consuming. So let's get into an example with some real numbers, and that should potentially make things make a little bit more sense for you. All right, so to find the inverse of matrix A, the first thing is we need the determinant of matrix A. And so the determinant of matrix A becomes AD minus BC. And so in this case, it's A times negative 4, 3 times negative 4, minus 4 times 4. And so that's 4 times 4. So 3 times negative 4 is negative 12. 4 times 4 is 16. So negative 12 minus 16 more comes out to negative 28. So that's not 0, so that means we can find the inverse. Therefore, A inverse is 1 over negative 28 times the matrix that switches around those two and changes the signs of those two. All right? And so this becomes, as we switch these two numbers around, this becomes negative 4 and positive 3. And then these two numbers here that were both positive 4s get changed signs. So they just both become negative 4. Now remember, it's scalar multiplication, so scalar multiplication is the distributive property on steroids. We're going to multiply every single thing in there by negative 1 over 28. All right? So first of all, negative times the negative is going to be positive, and then 4 over 28 reduces to 1/7. Same thing here. We're going to get the exact same thing here, and the exact same thing here. And then finally, for the last blank, we're going to have 3 times negative 1/28, which becomes simply negative 3 over 28. All right? Now, that's how you would manually calculate the inverse of a 2x2 matrix. Eventually, we're going to be using our graphing calculator. When we get down into this mess down here, we will be using our graphing calculator to calculate the inverse of that. But for now, at least you should know how to do it. And the key is that the determinant cannot be equal to 0, or you can't take the inverse of that matrix. All right? So we're going to use our graphing calculator to find the inverse of a 3x3 matrix. So we're going to enter this matrix, matrix A, into our graphing calculator. It is a 3x3 matrix, and so you'll notice here that there's a matrix button on your graphing calculator. On the 84, you have to hit Shift and then Matrix. For the 83, I believe it's one of the matrices. There's a matrix button probably in this region right in here. But in this case, because we're using the 84 version, you're looking for this matrix that's above the X inverse button right there. So you have to hit Shift and then go to Matrix. All right. Once we do that, then we're going to edit our matrix. All right. So we want to edit matrix A, and we're going to press enter. So once we select edit, we're going to just go ahead and click on matrix A and press enter. We want to enter a 3 by 3, so you're going to enter the dimensions first, 3 by 3, and you'll notice that the boxes down below in the matrix changes to a 3 by 3 matrix. From there, we simply enter the numbers, and it works across the columns when you enter them in. So if you press 3 and press enter, it works across. You'll notice it's working across that column. So 3, 2, -1, and then 7, 5, and 0. And then 5, 3, -2. And so there's our matrix, our 3 by 3 matrix. Now, we have to exit out of this matrix. So what we're going to do is we're going to hit second and quit. Otherwise, if you press the matrix button, it's going to try to embed a matrix within a matrix, and it just makes a big old mess. So hit second and quit and get yourself back out to the main screen, your main calculation screen. And again, now press second matrix. And you'll notice that matrix A is now a 3 by 3 matrix. So under the names of that matrix, if I simply press enter, it's going to spit out matrix A for me, which is the matrix, and it should. This should match exactly. This should match exactly with what we have here. So verify that before you do anything else. Now we want that matrix, we want the inverse of that matrix, and so what we're going to do again is we're going to hit second matrix, and we're going to select A. Now we want A inverse. Okay, we want A inverse. So the first thing we're going to do then is we're going to type A. We're going to get matrix A there. And then we're going to use our inverse button. Okay, we have an inverse button on our graphing calculator, and it should look like x to the -1 power. In this case, it's right here. All right, so we want to use that button, this x inverse button, to find the inverse of matrix A. And so now if I use my pen mode again and I press A to the -1 power, that's going to give me the inverse of matrix A. And now I can simply write down that inverse. Again, keeping in mind that this is going to give me decimals, but I know that -5, well, that's -5, but 0.5 is the same as a half. And this is 2.5, so if you want to write 2.5 or 2.5, that's fine. 7, -1/2, -3.5, -2, +1/2, and +1/2. Now, if you needed to find simply just the determinant first, there is a menu, there is a calculation menu under matrix. So if you hit second matrix, and you go over to math, the very first option here is the determinant. So we can calculate the determinant of matrix A by doing determinant, second matrix of matrix A. And so this is what we were talking about in the previous example. Here's how you do the determinant with your graphing calculator. But you'll need to know how to find the determinant of a 2 by 2 matrix without using your graphing calculator. All right. Now, the methodology behind how you find the inverse of a 3 by 3 matrix is a little bit more than the scope of the course. You should be able to do the 2 by 2 because you just flip the A and D and change the signs of B and C. So that's not too bad. For the 3 by 3, essentially, if you can find the determinant using the graphing calculator and use the graphing calculator to find the inverse, you should be in good shape. Okay? All right, so the next piece then is we want to take a look at using an inverse matrix to solve a system of equations. All right, and so the very first step in using inverse matrices to solve a linear system is it says write the system as a matrix equation, AX equals B. The matrix A is what we call the coefficient matrix. And I'll show you what that means in just a moment. It's the coefficient matrix. X is the matrix of variables, whether you have X and Y or X and Y and Z, a 3 by 3 matrix. And then B is the matrix of the constants, basically the two solutions. Okay, this is what we would commonly refer to as the right side of the equations. All right, now, the key to this is to do this, each of my equations has to be in standard form. All right, so they have to be in standard form, which we'll get to in just a few minutes here. All right. Now, the second step is to find the inverse of matrix A, and then because multiplication is not commutative, which we talked about in the previous lesson, because multiplication is not commutative, we want to multiply both sides of this equation by A inverse on the left. Okay, because when I do A inverse times A, effectively A inverse times A cancels out, and the result is what we call the identity matrix. Don't worry about that. But basically, then you're left with the solution matrix, which is X equals A inverse times B. All right, so we're going to solve our first linear system. We have the matrix A, we have our solution matrix X and we have our matrix B. And so the first thing we have to do is we have to find A inverse. Now, if you have a graphing calculator, which you all should at this point, you should easily be able to find A inverse. And A inverse is going to come out as the inverse of this matrix here, -3, -1, 4, and 1. So I'm going to use my graphing calculator to find that. If you don't have a graphing calculator, then you have to find the determinant of matrix A. Once you have the determinant of matrix A, that's AD minus BC, then you would do 1 over that and multiply by, and we talked about how to find that manually. We don't want to have to do that. All right, so going back over to my calculator then, I want to simply enter in second matrix, second matrix, and I'm going to scroll over to edit. Now I want to change A to be a 2 by 2 matrix. So if I simply press 2, you'll notice that the rows are reduced by 1, and when I press 2 again, now the columns are reduced by 1, and I'm left with a 2 by 2 matrix. I want to put the entries in as they exist, so -3, -1, 4, and 1. And again, make sure that you go second quick to get out of there. Now, we need to enter matrix B. So, second matrix, go over to edit, scroll down to matrix B, and we're going to then enter matrix B as a 2 by 2 matrix. So again, simply press in 2 by 2, and you'll see right now matrix B is an empty matrix. It's a 2 by 2 with all zeros. We're going to then type in our 9, 4, -12, and -3. 9, 4, -12, and -3. All right, now here comes the fun part. We are then going to simply find the inverse of matrix A by going second matrix. Here's matrix A, and I want the inverse of that, so I'm going to use my inverse button. Again, remember my inverse button is here, and so this becomes A inverse, and so matrix A inverse becomes, oops, I already had it there. A inverse is equal to 1, 1, -4, -3. And that's sure a heck of a lot easier than doing it the manual calculation method. So what we do then is we say, look, I have right now AX equals B, and so if I multiply both sides of this equation by A inverse on the left, these effectively cancel out, and I'm left with X is equal to A inverse times B. Now, A inverse is 1, 1, -4, -3. And matrix B, according to that, you can't see because the calculator's in the way, this is 9, 4, -12, and -3. Now, we practiced this in the previous lesson. You can certainly do this by multiplying matrices. Again, you multiply a row by a column and add the results. I'm not going to do it that way. I'm going to save some time. I'm going to simply multiply A inverse times B. And so I'm going to go back to my other mode here. I already have A inverse, so if I go second matrix, here's matrix A, press our inverse button, and I want to multiply that by matrix B. So second matrix, scroll down rather to matrix B, and now I see I have A inverse times B, and when I press enter, the A inverse times B is -3, 1, 0, and 7. -7, excuse me. And so this result simply becomes -3, +1, 0, and -7. All right, so we'll get some more practice with that on the next page. Go ahead and slide over to the next page for me, please. And let's take a look. Now we're going to be using an inverse system to solve a linear system. So an inverse matrix to solve a linear system. So just like we did before, what we want to do then is we want to write this as a coefficient matrix. So we want to take the coefficients of x and y and we want to put them in our coefficient matrix. We're going to call that matrix A. So this is 2, 3, 1, and -2. Multiplied by the matrix xy, which is my variable matrix, is equal to 15, -17. Now, how does this coefficient matrix times xy translate into this equation right here? Well, let's take a look. If I were to multiply, remember when I multiply matrices, I multiply a row by a column and then I add the results. So 2 times x plus 3 times y is equal to 15. So effectively I get 2 times x plus 3 times y is equal to 15. And as you notice, that's exactly the first equation in my system of equations. Again, multiply the second row. 1, -2 times xy is supposed to be equal to -17. 1 times x minus 2 times y is equal to -17, and you'll notice that's the second equation in my system. So now I have A times X is equal to B, like I did before. And so to solve this, I'm going to multiply each side of this thing by A inverse on the left. And so I get X is equal to A inverse times B. And so now it's just a matter of typing in matrix A and typing in matrix B into my graphing calculator and then using the command A inverse times B. So second matrix. Let's edit our matrices again. Matrix A is still a 2 by 2 matrix, and so my entries are 2, 3, 1, and negative 2. Again, second quit, second matrix. Let's edit matrix B. Now remember, matrix B is no longer a 2 by 2. It is now a 2 by 1. It should be 2 rows, 1 column. And the results then are the constants over here, which are 5 and negative 17. So 5, negative 17. Well, notice that that's the, I'm sorry, that's not 5, it's 15. Glad we caught that. So 15, negative 17 is our B matrix. And now, if I just press second entry, it brings back the previous entry, which is A inverse times B. We've entered our coefficient matrix, AB. We've entered our coefficient matrix already as A. We've entered our constant matrix already as B. We just changed them, and so again, the calculation we want is the solution matrix will be A inverse times B. And so now we go back over to our calculator, we press enter, and it gives us our result. This tells us that our solution is negative 3 and 7. All right, what does that mean? Well, my solution then is X equals negative 3, negative 3, 7. Now remember, X is this matrix X, Y, isn't it? So that tells me that X equals negative 3 and Y equals 7. So X equals negative 3, Y equals 7, or the solution is negative 3, 7. Now that sure beats the heck out of doing elimination or substitution or any of those other types of methods. We simply plug in our coefficients, we plug in our constant matrix, and we go from there. All right? So let's do a 3 by 3 matrix. All right? And by the way, if we were doing this with substitution or elimination, we would be here for quite some time. The matrix multiplication method saves us a ton of time on doing a 3 by 3. These coefficients are 1, negative 1, and negative 3. Coefficients for the second equation are 5, 2, and 1. And for the third equation, there's a negative 3 before the x, there's a negative 1 before the y, but you'll notice there are no z's, and so there are no z's multiplied by x, y, and z is equal to our constant matrix, which is 2, negative 17, and 8. So we've now rewritten our system of equations into two matrices, where I've got my coefficient matrix, actually 3 matrices, my coefficient matrix, my variable matrix, and my constant matrix. And like we said before, just multiply both sides by A inverse, and that's going to get these to cancel out, and so I'm going to be left with x, y, z is equal to A inverse, I'm just going to write A inverse because I have no idea what that's going to be, times 2, negative 17, and 8. All right? So now this in here becomes what we have to find. We have to find A inverse first. All right, so we're going to go back over to our graphing calculator. In our graphing calculator, second matrix, we need to edit matrix A. Notice matrix A is a 3 by 3 now, so we want to enter a 3 by 3. And we want to put in those values, again, the coefficients of x, y, and z. 1, negative 1, and negative 3. The second row should be 5, 2, and 1. The third row is negative 3, negative 1, and remember, since there are no z's, it's 0. Second quit, second matrix, let's edit matrix B. Matrix B is now a 3 by 1 matrix, and we want the values, the constants on the right side, to be these entries, so 2, negative 17, and 8. Now, we can simply press second entry, and that brings us back to A inverse times B. For those of you guys that need a refresher, again, second matrix, press A, use your inverse key, and multiply that by second matrix, matrix B. And so there's your computation. And so my solution is negative 9, negative 9, positive 19, and negative 10. All right, so going back over to my pen mode here, kind of got a little bit of a mess here, but x, y, z is then going to be equal to negative 9, 19, and negative 10. So that means my solution is x equals negative 9, y equals 19, and z equals negative 10. And so there's my solution. That saves me a lot of time with using elimination or substitution. We can't graph that because that would be in 3 dimensions. All right, so let's finish this thing. Here's a story problem. This is why we actually use matrices, to make this a little bit easier. We're going to define 3 variables. As I read through this scenario, it says a company sells 3 types of movie baskets. One of those, a basic basket, has 2 movie passes, 1 package of popcorn, and no DVDs. The medium basket has 2 movie passes, 2 packages of popcorn, and 1 DVD. And the third basket has 4 passes, 3 popcorns, and 2 DVDs. All right? And so what we're going to do is we're going to define our variables. X is going to be equal to the movie passes, the number of movie passes. I'm sorry, the cost. I think my head's in the way of the projector here. The cost of a movie pass. Y is going to equal the cost of a popcorn. And Z is going to be the cost of a DVD. All right, and so we're assuming that those 3 things are constant throughout the problem because it says find the cost of each item in the gift basket. So what we're going to do then is we're going to write the first, the basic basket. Well, that's 2 movie passes times the cost of a movie pass, which is 2x. 1 package of popcorn times the cost of a popcorn, which is y. And we have no DVDs, so again, if z is the cost of a DVD, that's 0 z's, and that's supposed to be equal to $15.50. All right. Next, in the medium-sized basket, we have 2 movie passes at X dollars a piece, 2 packages of popcorn at Y dollars a piece, and 1 DVD at Z dollars a piece, and altogether that's $37. The super basket has 4 passes, 3 packages of popcorn, and 2 DVDs, and that's going to cost us $72.50. Now, we want to write this as a system of equations in matrices. We have our system of equations. Our coefficients for the first line are 2, 1, and 0. We're going to be multiplying that by x, y, and z, and the solutions are going to be $15.50, $37, and $72.50. And so the first row is 2, 1, 0. The second row is 2, 2, 1. The third row is 4, 3, 2. Okay? Now, we're going to slide back over to our calculator. I'll give you just a second to finish writing that one down, or you can pause your video and write that stuff down. We need to do, again, this is our matrix A, this is our variable matrix, and this is my solution matrix, or my constant matrix. And so we're going to multiply both sides by A inverse. And so now we simply have to plug all of those things in. All right, so we're going to go back over to our graphing calculator, and we're going to put in that information. And I apologize, I can't leave the writing on the screen and control the calculator at the same time. So I'm going to go back and use my notes to plug this in. Under second matrix, matrix A has to be a 3 by 3 matrix still, but the numbers that I want in this matrix are now 2, 1, and 0. The second row is 2, 2, and 1. And the third row is 4, 3, and 2. And so 2, 1, 0, 2, 2, 1, 4, 3, 2. I want to make sure I have them in correctly. Now, second matrix, let's edit matrix B. And I still need it to be a 3 by 1, but now my solutions are going to be the results, which is 15.5, 37, and 72.50. Again, this is my constant matrix. And so it changes 15.50 and 72.50 into just 0.5, which is fine. Second, quit. And again, we want matrix A inverse times matrix B. And let's see if I can go back to my pen so you can see them both. So again, we've put in this matrix A. This is my matrix A. This is my variable matrix. This is my matrix B. And I did A inverse times B. And that tells me, and I'm going to have to write it up here, so sorry if you guys are running out of space. That tells me that X, Y, and Z is equal to 7, 150, and 20. Now, interpret those results, please. What does the 7 mean? Well, the 7, remember, was the cost of a movie pass. So that says each movie pass is $7. And I'll just put MP for a movie pass. All right. The popcorn, those are $1.50 a piece. and the DVDs are $20 a piece. And so in interpreting those results, that's what we get.